Hello again. In this video we're going to take a look at some of the structure of the distributed road network system. So let's start off by taking a look at our link base, and we notice in here that we implement iLink. iLink must have a length. We have some coordinates, get vertices list, and we can add to that. We have a global ID and a link type. In this situation, the link type can be a link or a sync or a factory. So let's go back here. Identifiable. Take a look at that. Basically, we just say we have to do a get group ID and a get local ID. We use those IDs when we're passing information around the global environment, the entire big picture world. So we just go through implementing the different aspects. We don't really use the coordinates in this overall system. We primarily end up just using the length of the links. Factories and syncs typically don't have any length to them. Factories are used to produce the cars, and syncs are kind of like the destinations or endpoints where kind of cars, if you can view it, are being consumed. So here's our concrete instance link, very basic, straightforward, pretty much just almost an instance of our link base. Take a quick look here at the connector. As you see here, we have our identification information again, and we have entry links and exit links. So if you can imagine, you pull up to a stoplight intersection at the street, and the section of road that you are on is an entry link into the connector, and say the section of road you're going to cross through the connector, and you're going to go over to another portion, another road area, another link. That would be an exit link in this environment. So then we basically have some straightforward stuff: adding an entry link, adding exit links, setting, creating it and setting the identification information, and satisfying our interface requirements, returning a list of the entrances, returning a list of the exits, getting the exit percentages. So say for instance, you think from this connector, 50% of the traffic goes to this link, 25 goes to this link, 12.5 goes to this link, and 12.5 goes to another link. So maybe you got a fancy roundabout, and you have those multiple exits off of it like that. Now we also have a vehicle factory. As I said before, this extends the link base. It implements an iVehicle factory. So take a quick look at that. Basically, if you are a vehicle factory, you must be able to get a shipment from you. So I go to the factory to get a shipment. We have the number of vehicles produced per hour, and we keep track of simulated time so that we can make sure we're meeting the vehicles produced per hour. There's our link type of factory. Time our calculations to make sure we're producing a car. Oh, you'll notice here that we are creating a specific instance of car. I'll come back around to that, and you'll notice the way we build the unique ID for this car. We're saying it's a generic car, our global ID, and then vehicles produced for all time would be kind of like our serial number or ID number, and it is 14.25 feet long. So let's look at our car here. Car extends vehicle base. So if we take a look at our vehicle base, we will see it implements iVehicle and identifiable. Again, we see that throughout the system. So if you're a vehicle, you must have a length and have a global ID. So we're looking at our vehicle base again. So there's our methods to satisfy our ID requirements. Base constructor. We'll go back and look at our car. Very simple, almost almost like an instance of the base, but it's the very simple concrete that we use up here in our factory, where we produce our cars at a set rate up here, and from here the cars go out onto the links. The update routine happens. They travel across and into a connector, and then eventually they end up in a sink. So that's kind of the basic overall structures: links, connectors, factories, and sinks, and the car that travels upon them. So thank you.